Now from stars onto galaxies. So a galaxy is a giant grouping of stars, interstellar gas and dust, and other stuff. The stars orbit around the center of the galaxy in elliptical orbits, similar to what we talked about with the planets orbiting around the sun. However, one big difference in the solar system, the sun contains 99% of all mass in the solar system, so it's like we have one central supermassive thing, and then all of the planets orbit around that. In the galaxy, it's not like that. There's not one thing at the center that contains most of the mass. Instead, the mass is fairly spread out. But this does mean that the planets do orbit around the center of the Milky Way in elliptical orbits. The galaxy that is the closest to us, in fact, we are inside of it, is the Milky Way galaxy. I hope that you've had a chance to actually see it in the night sky because it is stunning. Unfortunately, there's more and more light pollution around, which means that it's getting harder and harder to actually see. But if you're able to go to a dark sky area, absolutely try to see the Milky Way galaxy. It is best viewed in summer. On average, each galaxy contains around 200 billion stars. That's about how many we have in our own Milky Way galaxy. Again, the stars orbit around the center on elliptical orbits, similar to the planets orbiting the sun. From what we can tell, there seems to be about 200 billion galaxies within what we call the observable universe, the part of the universe we can actually see. I've once heard it said that there are more stars in the sky than there are grains of sand on all beaches on Earth. And if we're talking about 200 billion times 200 billion, that actually seems about right. Our galaxies tend to fall into three different categories, and we separate them based on how they appear, their shapes. So the three types, we have spiral, elliptical, and irregular. First, we're going to look at elliptical. Ellipticals appear to be giant balls of very old stars. They have very little gas and dust, very little interstellar medium, which also means that they have no ongoing star formation. They appear to be very old and appear to be dead, and that's about it for elliptical galaxies. Spirals are, at least for me, what I generally think of when I think about galaxies. These have a central bulge at the center and then a disk of stars spreading away from the center. So here is the central bulge, out here is the disk. The disk contains the spiral arms, which is where these galaxies get their name. It also contains a lot of interstellar medium. Because it has a lot of interstellar medium, these galaxies actually have ongoing star formation. Related to the spiral galaxies are the barred spiral galaxies. In this case, instead of having a central bulge, they have a central bar. So a bulge is nice and round right at the center. The central bulge is elongated, and the spiral arms then sweep away from that central bar. Based off of current observations, we actually believe our Milky Way galaxy is likely a barred spiral, not just a regular spiral. The last category of galaxies are the irregular. If it's not an elliptical and it's not a spiral, we still have to put it somewhere, so this is the where everything else goes category. These are the irregular. Irregulars come in two varieties. Some of them just have weird shapes with no particular structure to them in any way. Other ones appear to have been highly disrupted because of collisions. Only about 3% of all galaxies actually fall within the irregular category. Now, some galaxies are classified as active galaxies. What this means is they're putting out way more energy than a typical galaxy. So one of these active galaxies will actually be putting out hundreds to thousands of times more energy than our Milky Way does. Two examples of active galaxies are starburst galaxies and galaxies that have what are termed as active galactic nuclei. Starburst galaxies are what they sound like they should be. These are the galaxies with a burst of star formation. A typical starburst galaxy will actually have about 100 times more star formation than a typical galaxy. So in this case, we're actually looking at what's known as the antenna galaxy. This is two what used to be spiral galaxies that are in the process of colliding. As this happens, it causes a squeezing in of the interstellar medium, which is then going to trigger a huge amount of star formation. In the image, the regions that are bluish are blue because of a huge amount of star formation. The brightest stars are also the ones that are the hottest, which are the ones that are blue in color. The other type of galaxies that put out tons of energy are ones with an active galactic nucleus. An active galactic nucleus is a supermassive black hole that is at the center that is currently in the process of feeding. What we mean by supermassive is that these black holes have masses from millions to billions of times the mass of our sun. A black hole that is formed from a supernova, from a high-mass star exploding, tends to have masses between around 5 to maybe a couple dozen times the mass of the sun. On the other hand, we have these supermassive ones that are millions to billions of times the mass of our sun. As these things pull material in from their accretion disk, from this matter, some of it can actually get swept up in magnetic fields and get ejected away from the supermassive black hole, reaching near the speed of light. So these things are putting out huge amounts of energy. In this case, we're actually looking at an image of the galaxy known as M87, which is actually an elliptical galaxy. And down here at the center, that's where the supermassive black hole is. In this case, we don't actually see it. We see the bright spot that is surrounding it, and then this giant jet of material that is streaming away near the speed of light. Here is our last clicker question. The motion of individual stars in a galaxy normally follow A, elliptical orbits around the center of the galaxy, B, completely random paths, C, straight lines for the most part, or D, circular orbits around the center of the galaxy. Go ahead and think about it, and we'll discuss in just a bit. All right, so stars, as they orbit, are going to orbit similar to planets around the sun, which means they're going to have elliptical orbits. Stars actually orbit on elliptical orbits around the center of a galaxy. So the correct answer is A. Now, something that we have found is if there is one galaxy, there are usually other galaxies nearby. These clusters of galaxies we refer to as galaxy clusters because we're terribly imaginative in astronomy. So in this case, we're actually looking at the local group. This is the galaxy cluster that our Milky Way is a part of. It contains the Milky Way, the Andromeda Galaxy, another spiral referred to as the Triangulum Galaxy, and a whole bunch of dwarf galaxies that are satellites to these larger three. Altogether, there's somewhere around 40 galaxies within the local group. Well, as we've looked at where clusters are located, we found that if there's one cluster, there are usually other clusters nearby. These clusters of galaxy clusters we refer to as superclusters. Okay, what we have imaged here is referred to as the local superclusters. So we have the local group at the center, some other clusters in the area. We have the Virgo cluster and the Eridanus cluster. So we have this cluster of superclusters. When we zoom out even farther, we get this feeling that superclusters tend to form along these chains and lines that start to run throughout the rest of the entire galaxy. So taking another step out, as far as what we can tell, it appears that superclusters are kind of like a foam with large pockets of nothing in between. Okay, so you can think of like a whole bunch of bubbles. We find that galaxies, clusters and superclusters tend to form on the edges of bubbles, and in between we have these pockets of nothing referred to as galaxy voids. My personal research has actually been studying voids, which means that to some extent I am literally studying nothing, which is kind of fun.